Hi, in this video I'll be showing you how to assemble a packer to patch repair broken pipes. I'll be using a packer chassis which will allow you to repair pipes ranging from 2 to 6 inches in diameter. The chassis will support bladders made from various different materials, but we'll get into that later in the video. You'll be able to repair T or Y-shaped junctions as well as small patch repairs. You could even repair pipes up to about 15 meters or 50 foot in length. The advantage to offering your clients a patch repair solution is that you don't need to outsource your work to a third party. And the majority of the pipe rehabilitation specialists seem to be focused on bigger diameter pipes or more complicated techniques. So having the capacity to offer a patch repair solution is affordable, and there's actually a lot of profit involved in it. The reason being is that you are quoting not against another lining company. What you're quoting against is what the customer is paying to have that dug up and replaced the conventional method. So if you weigh these two prices up against each other, the difference is then your profit. And also the time it takes, and the dust, and the chaos. This chassis is meant for the CIPP method. The process involves building an inflatable bladder, which we call a packer, and then putting the packer inside of a felt liner that has been saturated with epoxy or polyester resin. The liner and packer are then pulled or pushed into position to cover the break in the pipe and then inflated with air. As the bladder inflates and expands, it forces the liner to take the shape of the internal diameter of the damaged pipe. This is then left to cure before the packer is deflated and removed, leaving only the liner patch inside the pipe. So many P's to say there. The set includes 2 ends for fastening different kinds of bladders and a flexible connection rod, which is 70 centimeters or 27 inches in length. The rod is mainly used for twisting T or Y-shaped bladders into position, but it's not really necessary for all packer assemblies, especially longer ones. One of the ends allows air into the packer with a compressor fitting. We call this the air end. The other end has a stopper to keep the pressure in the bladder, and this end comes with a T-slide connection. We call this the push end. You can use a drain rod to push your bladder into position, but it must have a T16 or T20 slide connection. If you've crimped a T-slide connector onto your flexible shaft, then you could use that to push your bladder into position. Personally, I prefer using the push and pull technique. This technique involves connecting a strap to both ends of the packer. This will allow you to pull or push in both directions, forwards or backwards. To do this, you'll need to remove the T-slide female connector on your chassis with a screwdriver. This will expose a 5mm hole through which you'll thread a reinforced cable and fasten it with a fastener, like this. This will allow you to connect a reinforced strap so that you can pull the bladder and liner easily into position. The advantage to this is that you can pass through multiple bends before you reach the section of pipe that you are repairing. A push rod won't really allow you to do this, but a push rod is again essential for twisting a T or Y-shaped bladder into position. Now, when it comes to choosing the materials for your packer, you could use rubber. Rubber is soft. It'll pass through multiple bends easily. It also gives you a nice smooth finish, but rubber has got some problems. The problem with rubber is that it does not react well with epoxy, and this could be a risk when the epoxy comes into contact with the bladder during the liner assembly. The liner and bladder need to be separated with a plastic sleeve like this. And just a small hole in your plastic sleeve could cause that bladder to get a little bit of epoxy on it, and as a result, when it's inflated, that surface becomes bigger and it loses integrity. So at some point we experimented with adding multiple layers of plastic, but still, if just a little touch, a little drop of epoxy gets onto your rubber, that's a problem. The other disadvantage to rubber is that it seems to only come in 20-meter lengths. So if you want to line anything longer than 20 meters, you're going to have to use some other technique. But as I say, the advantage is nice smooth transition around 90-degree bends. If you do have a failed liner, don't stress. We have chains and cutting heads that work with flexible shaft, and you can just grind it up and remove the failed liner and start from the beginning. But it is obviously inconvenient. More experienced users tend to be using calibration hose. It's cheaper, it's easily available anywhere, but it does have limitations. To start with, you can only really repair straight sections of pipe because PVC has a tendency to wrinkle when it curves around a 90-degree bend. This becomes a problem when you deflate your packer because the cured liner will end up pinching on the calibration hose and not allow it to be removed from the pipe. That can be a big problem. So only on straight lengths. Another disadvantage is that you might need more than one layer of calibration hose because, as you can see, this calibration hose has been sewn and then afterwards it has a seal on the outside. And in my experience, sometimes these leak. So having a double layer of calibration hose is advised, and definitely not on any 90-degree bends. A neat trick that I learned in the field is to inflate your bladder so that the liner takes up the inner circumference of the pipe. Then deflate your bladder just slightly, just for a few seconds, and then re-inflate it again and leave it for the curing process. In doing this, you actually iron out any little creases that you might have made during the initial installation, and it gives it a nice smooth finish. My favorite material is definitely a silicone bladder. Not only does it pass through multiple bends quite easily, but at the same time it makes a nice smooth finish. The best part is that it doesn't react negatively with epoxy. It is a bit more expensive, but well worth the cost. This is a Y-shaped sample, and as you can see, it has a nice, neat, tight stitch weld on it, and these are guaranteed to inflate up to 1 bar. I'll be using silicone to make up a small straight packer, but you can use the same technique when you want to make a T or Y-shaped bladder as well. The packer chassis will take bladders ranging from 2 to 6 inches in diameter. You could push it to 8 inches, but personally I don't have any experience with that using the CIPP method. We have 2 sizes available. The first is 28 millimeters, which is 1.1 inches, and the second is 38 millimeters, which is 1.49 inches. The smaller one is obviously meant for smaller packers, and obviously the larger one is meant for the larger pipe diameters. Building a packer is relatively easy. You're going to need some Teflon tape. I'm sure everyone's familiar with this. You also need some electrical insulation tape. You want the stretchy variety. It's very common everywhere. And some fasteners. Now, I've just got some cheap fasteners that I picked up at the hardware, but if you do an internet search, I'm sure you'll find some really fancy ones. The most important thing to remember with your fasteners is that you want this space here to be as small as possible, because this is a risk of getting caught on an angle or a bend or something along those lines. So that's the important thing to take into consideration when choosing a fastener. It is important to make sure that your packer doesn't leak. If it leaks, obviously it's not going to maintain pressure, and the liner will be deformed when it is cured. So we start out by applying Teflon tape to the fittings, like this. Now, wrap the electrical tape tightly around both ends to make a nice smooth surface. This prevents the clamp from damaging the bladder at a later stage when you're tightening it up. Do the same on both ends. Let me speed this up for you so you don't have to sit through the whole process. Now that both ends have a nice protective barrier, insert the packer rod into the bladder and pinch both sides of the bladder as close to the chassis as possible. Fold one flap under and the other flap over the chassis, like this. I'll show you again on the push end. Now, holding it firmly in position, wrap another piece of insulation tape over the folded bladder material and make another protective layer, which is intended to protect the bladder from being damaged from the fastener when you fasten it a little bit later. Now put on your clamp and tighten it up as tight as you can. Wrap a final layer of electrical tape around your assembly to ensure that the clamps do not get caught up on any bends or joints in the pipe. And voila, you have a packer. Now it's time to test the packer integrity and ensure that you have done everything correctly. For this, you're going to need a shut-off compressor valve and a compressor hose. Connect your shut-off valve to the compressor and inflate it to the appropriate pressure. Close off the shut-off valve and leave the packer inflated to make sure that no air escapes. When you've confirmed that the packer will hold pressure, then simply release the shut-off valve and deflate it. Now your packer is ready for patch repairs. As simple as that. Thank you for watching. If you're from the European Union, our website is Zewer-tools.com. That is Zewer-tools.com. If you're anywhere else in the world, except for the United Kingdoms, our website address is plumber-tools.com. And if you're in the United Kingdoms, our website address is plumber-tools.co.uk. Ciao!